To what we did in the last session. Towards the end, we tried to make a list of some unmet needs. About 300 odd of you identified the need, many could not. And we did circulate the form. So those of you who have not submitted or want to add something that you have already submitted to that in the form, you can do that. Form that was circulated by Ashwini last time, that form has an option of multiple unmet needs. Kindly do that. We will spend some time today as to what happens. How do we, first of all, identify the unmet need? And what happens when these needs are identified? How do we convert them into a research protocol or a policy change or an even institutional change and sometimes cultural change? I mean, the fact is that unlike Japan, where almost everybody used masks even before COVID, in our country, we didn't. And in some regions, people are now using masks more regularly than others. Some parts, it is being done more. Some of us are using double mask, but many people are still not using. It's a cultural change. But then came a very interesting idea. One of you mentioned that why can't we have mask dispensing machines in the labs and in the institutions? I think that's a good idea. It is a very good idea to have mask dispensing, just like we discussed last time about sanitary napkin, sanitary pad dispensing machine in the washroom. We should also have perhaps mask dispensing machine. It's a good need that you have identified. Now, somebody from CMERI or CSIO or some other such lab where mechanical gadgets are made, maybe one could devise that. So the next action would be that if some of you, as a part of your hobby project, I'm not saying it is not worth doing a thesis on because it's such a simple thing. And you can do in few hours, maybe a few days, couple of days, if 3, 4 of you work together, you will make a mask dispensing machine. It's very simple. Depends then how complicated or how detailed you want to make it. That's a different matter. But it is something that is easily fabricated. So can we expect that some of you will take initiatives to convert the unmet need into a solution, into a functional, practical design? And then on the top of it, if you make it open source, nothing like that. Put the entire design, bill of materials. I would say if you really want to make an effective open source, you should do 4 things. Put the design, measurements, each component, each part, each component. Second, identify the standard, do a standard component analysis, find out which are the components we can get off the shelf and which we need to fabricate, if at all any. Second step. Third step would be find out the vendors from whom I can get the standard components and the fabricators from whom I can get the specific component fabricated. Third step. Fourth will be the possible tests that I should perform to make sure that they are working well. The system is working as I expect. That's all we need in a DIY culture, do-it-yourself culture. We have not developed as yet in our country a very strong DIY culture, but we should work towards this field. There are slowly some designs are emerging. I don't know whether I mentioned last time, Dr. Dasappa from Indian Social Sciences, whom I had invited for a lecture for open source inclusive innovation for saving life, OSIS initiative of Honeybee Network. He had presented a design of oxygen generator, which he had developed, and he said the basic design he was willing to make it in open source, along with his student, PhD student, and more complicated one or more advanced one, people could license it from there. Now that makes sense. If somebody wants to have it a touch screen based or a sensor based dispensing so that you don't have to touch it at all, or maybe just a smartphone operated dispensing machine, those are advanced features and you could possibly put them under the protection if you wish to. I don't care really. So that would be one way. We will go into more details of this as we proceed today. But I wanted to tell you that you have moved in the right path, in the right direction. Today we will look at Let me put the presentation on, and then there are not too many slides, but there are a few that I want to share. So we will look at how we identify the unmet needs. Some of you have done it, which very well. Some of you have also identified the institutional needs, or I'm not institutional level need, but institutional need. That means needs which require either group action by the student themselves or by the lab or the institute. For instance, one of the things that many of you have mentioned is that you use hazardous chemicals many times and you put them all into the sink and they go into the drain, then go into the drainage. From drainage, they go into the water body. Water body, they affect fish, and fish sometimes comes back into our food chain. Or it may go into irrigation water. Irrigation water goes to the soil, and from there, it comes back into the food chain. So many of you have looked at that problem. Some of you have mentioned even radioactive material that you're using in your lab. And that is dangerous. I mean, that we don't want to go into the atmosphere just like that. There must be very systematic and safe ways of disposing radioactive waste. Some of you have mentioned about chemical, plastics, other things. Media, for example. Here we were looking at some of the needs that we identified, and we were discussing how one of the needs that you identified was a mask dispensing machine. And the idea was that if you want to convert into a prototype and prototype into a product, then a team will have to be formed of 5 or 6 people who will find a way of making an open design, finding the standard components, finding the fabricated components, listing down the supply chain members or vendors, and finding out the tests that need to be done to confirm that it is a robust design. This is what would really entail in creating converting an unmet need into a DIY solution. We also looked at some other problems that we have, such as waste of lab waste, lab water, lab radioactivities, and other things. Even the bio waste, for that matter, in the hostels and many other such problems, for which we need to design a good biodigester, which can be used by both at different scales. So we really do not have a biodigester which can be established quickly, which works in cold temperature and hot temperature, which works in humid environment and dry environment, and works well, and for which we have a starter culture of microorganisms which can digest the bio-waste faster. DRDO had, in the Gwalior lab, had developed a very interesting biodigester. I don't know if any one of you knows, otherwise I'll tell you a small story of how it was developed and how the unmet need of a biodigester was solved, not in the mainland, but at Antarctica. So what happened is that our delegation went to the Antarctica, and there you know that we have a research station there. India has a research station. So some scientists from Gwalior lab, DRDO lab, had also gone there. And they were trying to observe penguins, among other things, just like that. And they noticed that they were not able to find the excreta of the penguin in Antarctica. So they said, what do we do? So they searched, and then they realized that there is an organism there, a bacteria, which decomposes the waste of the penguin very fast. They brought that culture, adapted it, blended it with some other cultures, and developed a biodigester technology, which they licensed to large number of small entrepreneurs who used it in different parts of the country, including the railways. Indian Railways used a biodigester in the trains, where a lot of waste that was there could be digested in real time, so that they don't have to dispose of the waste on railway lines. So very, very serendipitously, maybe you can call it, but the discovery of a problem was by absence of a expected output, which was waste, excreta of the penguin. So that led to this solution. So the journey converting unmet need into a solution may require such stretched linkage of imagination or linkage of various observations and converting them into a prototype. So it is not always very simple that we can do that. You all are scholars and you know this better than I do. But I thought it was useful to mention that we need not look for solution very close to the domain of the problem. This is the first lesson I want to underline. Please don't look for solution always in close proximity of the domain of the problem. The problem was of biodigester. And where did we bring the solution from? From the penguins, so far away, and such a different environment. So please understand, even in Siachen, our forces have faced this problem. The human excreta doesn't decompose there. It keeps lying in the snow for years. And now we have a solution which will be useful to even regions like Siachen in the northern part of our country, or northern border of our country. So this is a very important lesson that we should not search for solutions to the unmet need very close to the domain of unmet need, because solution will lie somewhere else, and we will see that how we can look for that. Let's see further and go in terms of what are the ways in which we learn from the innovations. Now, you know that every grassroots innovation is a response to an unmet need. And I'll give you some examples. Why do farmers solve? Why do artisans solve problems? Why do common people solve problems? Because they have a problem. They have an unmet need and they try to solve it. But when we learn from them, it is very important that we should not learn only at artifactual level. This is the simplest level of learning. That means if there's a windmill and we make a windmill, that is same level. But we can learn at analogic level, metaphorical level. We can learn at heuristic level, thumb rules. We can learn at gestalt level, constellation of factors, institutions, culture, technology, science, as we discussed in the previous class. So there are 4 different levels at which we can learn from an innovation. And don't dismiss an idea just out of the hand if it is not seemingly belonging to the domain where you're working. And I'll give you an example today where we will see all the 4 applications, all the 4 dimensions of learning from one innovation. The second thing that I want to say is, second lesson that I want to share with you is that we can redesign things by paradoxical thoughts. What is paradoxical thought? Paradoxical thought is when we look at contradictions. So if you have a distribution, you look at the tails and contrast them, compare and contrast them. That is paradoxical. So let us look at this. There are different kinds of cycle-based solutions. Cycle-based sprayer, cycle that works in the water and on the road. Cycle is made of bamboo, cycle which is with a multiple gear, cycle which is used for spraying pesticide, cycle which is a workshop, having a drill, cutter, cycle which pumps water, different kinds of cycle. I'll spend time a little bit on the first design, this Kanak Das cycle. Kanak Das from Morigaon near Guwahati in Assam developed a cycle which converted the holes in the road, bumps into the road, converted that into energy and used that energy to propel the cycle further. What do we call that, anybody? When we have shock absorbers which generate energy, what do they call? There's a technical term for that. Anybody? So let us see what happens. So I shared this idea, regenerative shock absorbers, and I shared this in a class in 2007-8 at MIT. I was teaching a class on innovation. And there were students sitting there who observed it. Shakil Avdhani was one of them. In fact, he mentioned in a mail to me that, sir, I had got this idea in your class when you shared the Kanak Das. But MIT didn't want that to be acknowledged, because if they admit that, then they will have to acknowledge Kanak Das in the patent application. They did not. And I refer to that in one of my papers, that it was very unfortunate that an idea which we got from an innovator in India was converted into a product, as you can see here, but without ever acknowledging or sharing any benefits with that. This was very unfortunate. And I didn't want to come make it an issue, bigger issue than that. I just wrote about it in a paper, in a on inclusive innovations, and in a footnote, and mentioned that sometimes students cut corners, which is not good. It didn't really do good to them. It didn't good to connect us. But the point is, same innovation 20 years ago we gave an award, did not trigger any research in our country. Why? Anybody will give me an idea? When MIT student could get it in the class, trigger it, go back, develop a shock absorbing based regenerating system, file a patent, set up a company. And I shared the same in our country, in many places, including at our website, where we gave an award to Kanak Das from Assam, a maverick innovator, actually. Why do you think we didn't get triggered by this? Why didn't it convert into an innovation or product in our country? What could be the reason? Anybody? Why do you think we did not convert? Why don't we get provoked by such ideas? Another example that I gave in the same slide was of Amphibious Cycle. Saidullah Saab developed Amphibious Cycle way back in 70s. Now we are going to get monsoon next month, within the next few weeks. There'll be floods. And we need Amphibious Cycle because you can't carry a boatload of people all the time. So you want to go alone, distribute medicines in different marooned houses in Eastern India. And the amphibious bicycle could be very helpful. But we haven't a single amphibious bicycle, the bicycle which runs on the road and in the water, in any fire brigade office or any public health office or primary health center for distributing medicines, for distributing milk for the children, or any other essentials. Not one. He developed in 1972. We gave him an award. In fact, he once said, and I'll say it in Hindi because we wrote an article in Honeybee newsletter with his quote, which he said, "Agar mera saman hai sahi, to main kyun raha wahi ka wahi." If the innovation that I made is good, then why didn't my life change? It didn't change because we didn't convert that idea into a commercial success. And I must admit our failure also in that. No point in blaming only the market or state. Sorry, I didn't see. Now, Ashmika, this is all right that we sometimes develop solutions where risks are low and uncertainty is less. But there's no fun in that. There's no fun in that. If we take up, I in fact ask many times my students that we should maximize uncertainty. When you maximize uncertainty, even a random chance makes sense. You know that. Incentives, I'm not sure. What incentive do I need to solve a problem except Swanta hai Sukhai? That means for my own happiness. Ultimate incentive is what I give to myself. I don't need incentive from outside. Do I? I'm not a horse who needs to have a carrot in front to run. No, I'm a human being. And we discussed last time that there are intrinsic motivation and extrinsic motivations. The resources, I'm not sure. I don't think the resource is the problem. You have wonderful labs, you have wonderful workshops. Let's go further. And I've given you two examples in this slide. And my concern is that need is very well identified. We need cycle which can run on the bumps, with the potholes on the road. And every time the cycle jumps, the shock absorber in the seat, in the pipe, which is below the seat, will generate energy, which will be transferred to the wheel. So it's a good solution. He did it. No, Shota, you're right. But who will amplify? We have to amplify. And the question is, the possible application of this solution is huge. Imagine how many regions of Eastern India get inundated every year in parts of Orissa, parts of Bengal, parts of Bihar, parts of Assam, every year. Lack of scientific acknowledgement, lack of encouragement. Yes, you can say to some extent, but Niharika, my point is, who will encourage me? The Mavericks don't look for encouragement from outside. Again and again, I'm repeating that. We need to get that satisfaction, that joy, that happiness from within. I mean, yeah, you can say that, sir, it is easier said than done. We all need incentives. But truly speaking, if you ask me, any scholar, any outstanding intellectual in your lab, in your institute, anybody who you respect in your profession, just write down on a piece of paper, do an exercise, write down 5 outstanding achievers of your domain, in your domain, 5 outstanding achievers of your domain within the country and outside the country. And ask yourself, what was the incentive these 5 people got in their life to make that outstanding achievement, both applied and basic? So I would say that you might get an answer yourself. You don't have to wait for an answer from me. Just do this simple exercise. Write down the name of 5 role models who you admire from within, in your discipline, in your domain, in area, or for that matter, people who you really admire for whatever reason. And then check, what incentives did they care for? Did they care for? They may have been recognized afterwards, after they made this solution. But when they were solving problems, what were they looking for? Lack of awareness, yes, could be reason. And that is why this course is. I would really encourage you all to look at the database of NIF, National Innovation Foundation, nifindia.org, look at the database of gyan.org, look at the data of srishti.org, look at the data of techpedia.in, and you will find thousands and thousands of ideas, thousands of ideas. Pick up anything that you want. As a provocation, this is the point that you mentioned, that it might not work, it might fail. This is a killer. This is a killer. Many times, as I said, all of you who are here in the class today and were earlier there have been murderers of your own ideas. Each one of you has murdered one or more ideas of your own. Isn't it true? Is it true?
Yes, sir.
And you have done it ruthlessly, just by the argument that I mentioned that, look, it might not work, but let the time tell whether it will work or not. You satisfy yourself, your curiosity. So please, please, for God's sake, don't blame anybody else. We are the worst enemy of our own ideas. We don't write them. We don't discuss them. We don't share them with our colleagues, even if they make fun of them. And sometimes the colleague may be not in the lab, maybe another lab, maybe your school friend, maybe your college friend, maybe somebody else who is working in the same domain, a stranger, and you send a mail to the stranger. Look, I read your paper. I found it very interesting. I'm working on this problem. Can we work together? And that is it. A new partnership has been born. I know so many, I have made so many friends like that who I never knew. And they wrote to me or I wrote to them. There are many students who write to me from around the world. And I would say, yes, you're asking a good question. Let us pursue it further. I also learn in the process. They also learn in the process. That's a reward that we get. So let's go to the next and then see. I'll keep asking this question. Keeping the obvious out. One of the ways in which we identify the unmet need is not having the obvious. Let me give you an example. So there was a workshop we did of children. And we asked children, find out different ways in which cycle can be used, except to transporting people, transporting goods. These were the 2 obvious uses of cycle. Took them out. No more. We don't want to discuss that. Can you imagine? These little kids came out with a paddy threshing machine. They came out with a winding machine for wire, harvesting machine, cutting grass, sugarcane juice, a blower. All this is by children, little kids. And we had this workshop done in Rashtrapati Bhavan where we used to organize, Honeybee Network was organizing at that time with an Festival of Innovation when Shri Pranab Mukherjee was the president. And this workshop, and in this particular workshop, Professor Muhammad Yunus was also present, the Nobel laureate from Bangladesh. So look at this. This could happen in 1 minute. Sorry. And somebody said, we will generate charge. Somebody said, I will pump water from the well. Somebody said, I can clean the street, convert vertical motion into a horizontal motion, a Weber gear. That's it. That little child could conceive of Weber gear. Somebody for grinding the grains. All this by kids. We are grown up, but there's a kid in all of us. That curious, little, mischievous child in all of us. Don't let it grow up. Let him play with ideas. That irrepressible, irreverent child in us who enjoys solving problems, giving crazy ideas. But we just snub that kid. Keep quiet. You don't know what this word is about. No. Here, people don't like such ideas. You're crazy. And we quieten that kid in us, and our ideas die away. And we don't even write obituary of those ideas because nobody knows about them ideas. Don't do that. Don't do that, please. So stating the obvious out. This is one of the ways in which unmet needs can easily be identified. So what do? Whenever there's a problem, we will say, we will not look for obvious solution. One of you mentioned in your unmet need in Excel sheet, the very first student from, I think he was from physics lab, his background is in radiation. This is Abhijit Vishnu, you are from EMPRI, Bhopal, chemical science, and you're working on radiation protection. So I made a comment here. Abhijit is working on radiation. And I said, have you heard about gum karaya? Gum karaya is extracted from a plant in the forest near Visakhapatnam. There's a forest nearby, and this gum is collected by the tribal people. And look at the creative imagination that scientists, when they were studying the properties of this gum, they found that it could be used for developing anti-radiation barriers or anti-radiation screens. And they developed one. And the BRC and some other institutions were involved, and they did research, apart from any other application of this gum karaya. Now, how do we connect this? The need of tribal people to find high value from a forest-based produce, which is a gum that they collect from the trees. If it is used for low-end purpose, then they will never get good price. They will not get good price. Their poverty will never go away. They will continue to live in penury. Their children will never get education. If they get education, they will not get good education. If they get good education, they may not get good connections. They may not get good jobs, and so many barriers for the growth of, unfortunately, the children belonging to such social backgrounds. And by adding value, which for some of you can do, and which Abhijit could have done because of his background in radiation research, he could have developed this product, take it forward, and then set up an enterprise, maybe a startup, and supply it to the nuclear power projects or labs where nuclear radiation materials are used, so that for safety of the researchers and scientists. He could do so much more. How do we connect this? How do we make this connection? And that is a $1 million question, that these connections will require us to think very laterally and think in terms of exhaustive literature. So let me get to the next problem. So this was keeping the obvious out. If there's a gum, I'm not using it for pasting. I'm not using it only for food. As you know, many gums are used for food. I'm using it. आपको मालूम है लड्डू बनाते हैं ना गोंद के, जब बच्चा होता है तो माँ को देते हैं. So many times, let me repeat in English, that when the when a child is born, after the delivery, mother is given sweet meat made of gum, certain kind of gum, babul gum, and certain other gum. They are supposed to give a lot of energy to the mother. Yes, Bete, you are right. You're absolutely right. You must have been fed well. So now we go to the next issue, which is a change not monitored is a change not desired. And I'll take 5 challenges: water, food, energy, shelter, and health. Just 5. And in each case, we will try to identify some unmet need. Then ask ourselves, when we identify the need, why don't solutions emerge in our society? So let's go to the water. And in water, I will take one problem of water, which we came across in our Shodhyatra in Dhimaji in Assam. The water in Assam, in Dhimaji, was having very high iron content. So naturally, the conventional filters will not work there. So you need filters which can remove iron. And you know that such filters exist. But in the market, I couldn't find. So what do the people do there? They make a filter of clay and pebble and ash. And then they will filter the water from one canister on the top, below, second canister below. Water comes out clean. We filled up the water in our bottle. We walked for some time, 10 yards, 20 yards, and the water became brown. That means there was dissolved oxygen, which got oxidized and became brown. So their solution was suboptimal. Now, grassroots innovations many times are suboptimal solutions. I must not hesitate in saying this, which means they are work in progress. So some of you who work on water chemistry, and I have looked at all the patents of CSR. I have got a spreadsheet of 9,000 patents filed by CSR till date. If any one of you is interested in analyzing this data and finding out, for example, water, I can share with you a case study that I did with Zygam and Devika, two of my students who made this database possible and other databases possible. Some lab has filed one patent or two, somebody has filed 3 or 4. There are about 12 labs which have worked on water filter. But there isn't a robust water filter in the market which has come out from CSR labs. Yeah, problem here. What's the problem? So there are 2 or 3 problems here. One, that Dhimaji would need only limited number of water filters. A big company may not like to invest in it. A small enterprise might like to do it. And I've put a review on May 1, 2021. Natalie Bridges has put 12 best iron filters for well water reviewed and rated in 2021. There is a website, saveourh2o.org, and you can read that paper there. May 1, 2021. And don't be surprised if there's none from India, because we haven't worked on this problem. We know there are regions having fluoride in water. We know there are regions which have nitrate toxicity in water because of a lot of leaching of nitrates which are applied as a fertilizer in the agriculture. We know all these problems. We know all of these problems. Why do you think we are not working on them? Anybody? These are well-identified need. Problem here. What is the problem? Anybody? And you can't say this is we are not aware. This is reasonably well-known problem. We have very different in different parts of our country. We have different problems, different kinds of water problems. We have arsenic problem, and I'll come to a very interesting grassroots knowledge about arsenic water, which we have ignored to our peril. Yes, let us look at inertia. The question is, Sachin, that we know that there are different kinds of water problems in our country. Somewhere fluoride, somewhere arsenic, somewhere. In arsenic, at least some good work has been done, but in case of iron, in terms of fluoride, in terms of nitrates, we don't have good water filters. So we haven't developed water filters for the people who live in these regions, low cost, or even for that matter, made by private sector or public, don't care, but we don't have good water filters. And portable water filters, not at all. So when we walk in different parts of the country, as I told you. We have walked in every state of the country, more than once in many states. And during this walk, we come across problems as well as innovations. Ashmika, I don't know if really it is true that we have not identified the problem. We know the problem. I mean, problem of hard water, who doesn't know? Many times in your garden, when you put water from the tap, the plants, the roses will not grow because your water is hard. So you know there are. Then why do you use RO, which is a very bad solution for water filter, but nevertheless, many of you use RO. Why do you use that? Because you know that there's a high salt content. The more deeper we go for getting groundwater, more minerals are found in the water. We all know that. That's a geophysical fact. And CGRI, somebody must be there from CGRI here. You could explain to everybody that is something very basic. Every student of geophysics would know that, isn't it? And yet we don't work on this problem, or at least our solutions don't reach as far as they can. About arsenic, let me tell you what we found. One of our students was working with me. He went there and he found something very interesting. He found that in the open well, there was no arsenic. Only in the hand pump there was arsenic. That means oxidation process which took place in the anaerobic conditions almost, which led to the leaching of arsenic, was evident in the case of hand pumps, but not in the case of open well. But open wells had been left unattended. They had been abandoned by most people in the villages in Bihar, I'm forgetting his name, where he did this study. And solution was simple. In arsenic affected areas, don't propagate hand pump. We invented this problem. It was not there. We created the problem. Bad science and bad technology. Science was not bad in the sense that we didn't do good science, but we did bad technology. Simple solution. We should have simply seen under what condition arsenic is released in the water and whether those conditions are fulfilled, in which conditions. And then we should have asked ourselves, paradoxical solution will be, which are the conditions under which arsenic will not be released? And the answer would have been open well with lot of oxygen, lot of air. Now, these are the problems. Of course, Roshni, that is true that you should remember one thing, that the water recharge is a very sensible advice, very sensible advice. We have some good solution, but not very good solution. I do not know whether your lab can claim to put all the rooftop water and surface water flow into the aquifer. Ideally, every lab should put on a wall outside its boundary a water budget. Ideally, yes. But without distracting, let us come back to the point that if we are taking water from deep layer, please understand that aquifer which can be recharged will be shallow aquifers. But the water we are taking from 800 feet to 1,000 feet, sometimes more than 1,000 feet, this water is the fossil water, water which was made, yes, Manoj, when the earth was formed. This is the fossil water. This water will never be replenished. So, yes. Look, I can see your point. I can see your point that you are saying that if you take an uncertain problem, but thesis has nothing to do with the complete solution of the problem. If so long as you can define the problem better, you can still get your thesis granted, isn't it? So it is not necessary that. So please understand that there is a problem here, and we are not able to solve that problem. Let me go to another aspect of minerals. So we were talking about salts which are there in the water and which cause problem to us. Now we will look at the salt. That is the point. That is the point that sometimes when we don't suffer, we don't realize the problem. But then shouldn't we have a mechanism of Shodhyatra? I mean, each one of you should. So what I'm trying to say is, now let's move to the next problem, which is minerals in the soil. We were looking at minerals in the water. Now we will look at mineral in the soil and then see. Look at the minerals in the soil. What do you think can be the best? What are the possible advantages of minerals in the soil? Anybody? What kind of new opportunities of growth and development in our country will develop by looking at the minerals in the soil. I mean, there are some clues here, but I assume that some of you will understand, some of you will not. But still, let me know. What is the potential industrial application of soil minerals vis-a-vis food industry? Anybody? Yes, Vaishnavi. So micronutrients will be there. What will we do if we have biodegradable packaging? Okay. But what can we do with the minerals in the soil? How can we use minerals in the soil? What kind of potential industries be identified and developed by leveraging the data on soil mineral properties? Mineral-rich food, right? Very true. So there are two kinds of food, some which naturally mobilize mineral from wherever they are. So if you have ragi, ragi will mobilize more calcium. We all know that. So people who have pain in the joints or who have arthritic problems and so on might benefit from ragi. Yes. So what did we do? What can be done? If we know the soil mineral properties, 3 or 4 things can happen. And I'm just giving you an example how traditional knowledge can be of great help to us. So maybe I gave this example last time, but I'll repeat it if I did. And if I didn't, let me mention that. In the World Food Congress, which was organized at CFTRI, when Dr. V. Prakash was the director, he invited me there. And in my talk, I had mentioned that in Africa, we found there were some villages which had much less arthritis. Did I give this example before in the previous class about arthritis and haze?
No, sir.
No? Okay. So there were some villages where arthritis was found to be present. Large number of people were affected. And some villages, people were not affected at all. So scientists did a study and they found that regions where arthritis was present less or no were the regions where people were consuming local varieties of maize, unlike hybrid. And local varieties of maize, they found, could mobilize 4 times more boron from the soil than the hybrid maize. Boron, as some of you might know, is indicated in the metabolic pathways for arthritis or pain in the joint. Now imagine we have a map and we look at the soil nutrient map, and then we label the crops which naturally mobilize more nutrients, more minerals from the soil, whether it is copper, whether it is boron, whether it is zinc, whether it is molybdenum, whether it is magnesium. So if you have a problem of your hand shape, what you call that, Alzheimer or some other problem, magnesium is very important for you. And some of the seeds have it. Cucurbit seeds have high magnesium. You can also get it from some other foods. And if the soils are rich in magnesium, then and if the food grown there mobilizes magnesium, then that food will become a food for health. That means a functional food. Now, in our country, there are some examples of that kind. Flaxseed was sold at 100 rupees a quintal. Now it is sold almost 50 rupees for 100 gram. 50 rupees for 100 gram. It used to be sold for 100 rupees for 100 kg. Can you imagine? And nothing has changed in the crop, just the characterization. What scientists have done, they found that it is a good source of 3-omega fatty acid. That's it. And a new industry emerged. And now we are paying so much more. So this is possible. This is what science can do. So what is the unmet need here? The unmet need was information, knowledge. Scientists gave the knowledge. Where did they get it from? They asked people who consumed this flaxseed. Why do you consume it? People said, this is what the advantage is. They said, oh, this advantage could be because of this factor. And then they went backward. And then they did science and they established it and they shared it. And the problem was solved. Why wouldn't this research be done more often? I'll come to some other examples. Why don't we do more of this research? Why are we not coming out with more and more? For example, brown rice. There's a paper I've given in the hand from Anna University. Nutritional and functional properties of colored rice. Anthocyanins are much more there. Many of you who work in the food chemistry, biochemistry would know this very well. How many packages get good quality science and thereby generate market for people to grow these varieties? They are less yielding. They may yield less than the white rice, but they may give more money to the farmer. And agrobiodiversity is conserved. So we are solving many problems. We are conserving our habitat, we are conserving our agrobiodiversity, we are conserving our nutrition, we are conserving and we are improving health of the people. Everything is good. And resilience, climate resilience is increasing because of biodiversity. So yeah, I'm talking about soil fertility can be improved. You are right. But I'm saying that the already minerals which are rich, we can mobilize those crops. Of course, those which are deficient, we need to inoculate and supplement them. That's very true. I agree with you. That part is known to some extent. Now people have become conscious of applying micronutrients to some extent. But mind you, we still don't have a good machine for precision agriculture. Long time ago, CSIO, Chandigarh had developed it, guys, but didn't go very far. I have not seen it in field. We don't have sensors for various micronutrients. Now, this brings people from electrochemical sciences together and agriculture or nutrition science together. We should have sensors which will sense boron, which will sense calcium, which will sense magnesium, which will sense various nutrients, zinc, selenium, in trace quantities. And then a dispensing machine will move in the field. Grid by grid, we would have mapped the macronutrient, then we will disperse, release as much quantity as is required, where it is required, not everywhere. That's what precision agriculture is about. Why couldn't we develop probes? I told my friend Ashok Jhunjhunwala in IIT Madras once, he's a good electrical engineer. I said, why don't you help us develop probes for various micronutrients? Low cost. Farmers should be able to use, even a bullock plow can have a device, and with a app which is attached to the phone, he can make a map of micronutrients in the field. They are unevenly distributed because of drainage and soil formation. He will not have to apply the same nutrient everywhere. He will apply only where it is required and how much it is required. So what is preventing us from doing this? Please tell me. Why are we not developing these solutions? What is the barrier? Neither are we developing many functional foods, nor are we developing precision agriculture tools. We are not developing probes for sensing the micronutrients in the soil. We're not developing dispenser for the micronutrients, grid by grid basis. Why are we doing that? Lab to field translation. Vaishnavi, answer this question further. Please tell me, what should be done? First of all, are we doing good research of this kind in the lab? Are we having solutions in the lab? And then the next question will be, if we have in the lab, how do we translate them into the field? So let me get some examples of solutions that you think you have, which can go to the grassroots community, but because of lack of translational facilities, they are not going. And maybe we don't have to restrict to these examples of soil mineral and water mineral, but if you wish to, you can take another example also. Anybody would like to give some examples where what Vaishnavi is saying, the lab to field transition or lab to field translation is not yet evolved properly. And I agree with that we don't have a mechanism of translational research We don't have an on-farm trial system. We don't have an extension wing in the institutes, except in aroma mission and some other areas where IHBT and some other labs have done very well, CMAP. But other than that, and there also it is the demand that they have created for which farmers come and collect it from the lab. That's what they have done. At least 2 labs have done very well. They have converted the solution in the field lab into the field solution by making it so attractive for the people that they make a queue, they make a line there, wait for the seeds and take it from the lab. But other labs have not been able to do that, maybe because the scientists are much more interested in solving complex problems. And this is a muddy problem of going to the people, making it possible to grow there. I don't know. Yes, communication will help users. How do we encourage you to talk to the users of your solution? What should we do in this course? What should we do within this course in over the next month, by which each one of you can talk to some users of your skill, some users who are likely to use your technologies? How do we encourage you to talk to either some farmers or some mechanics or some entrepreneur, some industrialist? Supposing you are working in ceramics, you are in CGCRI. Anybody from CGCRI here, from Kolkata? Once we were doing a study long time ago, there was a member of a committee when Narasimha Rao was Prime Minister, Dr. Hanumanth Rao committee on drought, and we were looking at different examples of using knowledge about remote sensing for water management, etc. So in Nandyal, which was Prime Minister Narasimha Rao's constituency, the remote sensing people in Hyderabad gave us an example that they found that some of the tanks had been taken on lease by 2 ceramic tile making industry. That was very queer. Why would ceramic tile industry take tanks on lease? So they said they will desilt it, they would take away the silt of the tank and make tiles out of it. Now this is a paddy growing region. In a paddy growing region, you know that the straw of the paddy has very high silica content. I'm sure many of you know that, don't you? So this silica goes into the silt through drainage, and this silt becomes very useful material for ceramic. Now you know ceramic is the material of future. The tiles which covered Apollo mission to space were made of ceramic, because ceramic can tolerate up to 4,000, 5,000 degrees centigrade temperature. So imagine if we mapped the silt of different tanks in the paddy growing region in the country and characterized the silt and invited the ceramic industry of different kinds. Different kinds of ceramic could be made by different kinds of tank silt. Farmers will benefit because their tanks will get deepened every year, so they can store more water, they can irrigate better. Industry will benefit because they will get high silica content and different kinds of silica contents, soil, silt. Why don't we do that? Puneet, please tell me, what are you doing?
We are working to measure soil fertility attributes by using IR spectroscopy, and we're trying to develop the sensors for all this nutrient and micronutrient systems at CSIR Chandigarh.
And these sensors will work in the field condition, in the muddy condition?
Yes, sir. We are trying that these work in field as well as in lab conditions.
Lab is okay, but you know, we need to, I mean, I'm happy that you're doing this, Puneet. This is a very strategic work. I wish it was done 10 years ago, but it still is not too late if we can do that.
Yes, sir. We are working on it, sir.
Very good.
We are working for lab conditions also.
Yeah, but
field conditions also.
Field condition, that's very good. That's very good.
Yes, yes, sir.
And if they are robust and they can do that in a close, with a narrow range of error, that would be wonderful, because that will save so much of nutrients for our country. That will reduce the cost for the farmers and will save the minerals which can be then applied to more fields.
Yeah.
This is very important that we do this, but I was just mentioning that the characterization of ceramic. I mean, we can be the global leader in ceramic, which is a material future, by characterizing, by making a kind of a periodic table of silt of different tanks in different kinds of region, agroclimatic conditions, drainage conditions, paddy varieties. Different varieties of paddy may have different kinds, different content of silica and other minerals, which will then give different attributes to the ceramic made out of that silt. I mean, this is a kind of a research which requires a very different scale of imagination. It will require a very different scale of cooperation. Yes, Rupaprata, we should talk about this, and Puneet and you should talk to both of you and work out this idea. This is a beautiful idea that you can work together and work out and develop a solution to this. So let us look at this. These two examples that I took from water and food so far. Let us go further. Let's go to energy. And here you have three pictures. Jyoti is, let me correct it. We met her in Arku Valley in Andhra Pradesh. She had a small shelf on the top of the stove where cooking was done. And she will put paddy panicles after harvesting here. So the heat will go from the stove and heat the panicle. When it will heat the panicle, the rate at which the husk expands and rate at which the grain expands are different. Look at the beautiful physics that this tribal girl is using. So what is the implication? Can you tell me what is the implication of this? If both of them expand at a different rate, what is the implication? Anybody? Anybody? What is the implication? Yes, yeah. Well, yes, what you are saying, segregation is actually, you're right, threshing. Threshing is, so what she did was that now the separation of the husk from the grain is possible easily. The waste heat has been used to save her drudgery. Isn't it nice? Look at what is being done in Meghalaya. There are 4 shelves above this stove. Can you imagine what can we teach them about energy efficiency? So there is a stove at the bottom, first shelf, second shelf, third shelf, and then there is a great bag of seed hanging on the top for fumigation so that pest don't attack. Now, first one, they keep wood here. Many of you who are a student of material science might know that when wood is heated, it's called curing, it becomes stronger. So in Meghalaya, people use trolleys to transport goods, water particularly, and they make trolleys of this wood. So second, because it was from Cherrapunji, 35,000 millimeter rainfall, so firewood had to be dried. So second shelf, they put the fire. When did I become mute? Did I mention the example of Meghalaya or not yet?
Not yet, sir.
Okay. But Arku Valley example I had given, that you understood, no? The example of how the rate.
Yes, sir.
Yeah,
Yes,
okay. Yeah, so let me go to Meghalaya example. Meghalaya, this is from Cherrapunji. It received 35,000 millimeter rainfall. And there are 4 shelves here above the cooking spot, cooking stove. 1, 2, 3, and the 4th is a bag of seed hanging on the top. First one is these sticks. These sticks are used for making trolleys. In Meghalaya, people use trolleys for transporting water or other goods. And the wood becomes stronger when it is heated. It's called curing process. Some of you in the material science might know it. Since this region, Cherrapunji, receives 35,000 millimeter rainfall, highest rainfall in the world, the firewood needs to be dried. The second shelf has firewood. The third shelf on the top that you see has cheese or meat, which is dried for preservation. So what has she done? The temperature gradient has been used for functional purposes. What can we teach her about energy efficiency? In our homes, we have a gas. Flue gases go out in the atmosphere and they warm up the atmosphere. We don't have a shelf on the top where we can have leftover vegetable slices, cucumber spice slices, or bitter gourd slices, or tomato slices, or apple slices, which can be dried up there with the waste heat and used as a snack later on. We don't do that. We don't even use it to dry the clothes for that matter in the monsoon. So this heat goes waste. But here, an illiterate lady in Meghalaya was doing this during our Shodhyatra when we discovered this. It was mind-boggling that how the shelves have been placed at different heights depending upon the temperature required at that height for that functional purpose. It's a beautiful example of physics being practiced in day-to-day life. So if you let this innovation teach us, not just, yes, first is for wood for making trolleys, second is firewood, third is cheese, meat, or turmeric, as you mentioned, for storage, and fourth is, of course, the seed. The point that is being made here is that they could convert, illiterate people could convert the energy efficiency into such a good system of conservation and utilization of a temperature gradient. Why are we not able to learn from this? This is the question that we have. Similar in Mizoram also, they store seed of cob, full cob, they have wood, and they have other things drying, and the heat is, the stove is below. So in Andhra Pradesh, in Meghalaya, in Mizoram, all the three places during our Shodhyatra, we observed these beautiful examples of converting waste heat into functional output. Now, it should require a change in our kitchens. In our kitchen, we have a gas, and the gas heat from the vessel that we put on the gas goes into the atmosphere. We don't have a shelf, as I said earlier, where you could dry the slices of different vegetables and fruits and make them into snack. So, Janabi, yes, you are right. You may be doing in Assam also. My question is, Janabi, why wouldn't these observations trigger good quality experiments? And maybe we can optimize this. We can optimize the height. Maybe we can make them better. Maybe we can give them some tips about the way heat needs to be moduled. Maybe we can take away the soot and keep the heat intact. I do not know, because as you can see, the walls are very black. So soot has already covered all the wall and the roof. You can see that. But maybe soot has some of its own implications. I don't know. Maybe it has some antibiotic properties in this case. I mean, there may be carbon nanoparticles here. We don't know. You may know better. So there is a science to be discovered. There is a lesson to be learned. Now, there is a waste heat produced in our labs. There's a waste heat produced by our machineries, our scientific instruments. We don't think about. One of you mentioned in your unmet need that there is an air conditioner in the lab, and the air conditioner drips water, and this water can be used. You used a particular term, but of course it's a distilled water. It can be used for batteries. It can be used for various experiments. So one of you has observed this possibility, though this is known to all of you. But what about waste heat? So let me give you an example where you will find one student had done this. And let me see if I have this example. No, let me tell you first. So one student did something very interesting. His name was Dhruv, from a very ordinary engineering college in Gandhinagar. He said refrigerator produces heat out of compressor. What can we use this heat for? Any one of you? Tell me what you would have done. What can you do with this heat of the compressor of refrigerator?
So room heater?
Room heater. Well, in winter, yes, but in the summer, it will make the room very hot. Any other functional use of this heat? Heating water. Okay. Can you convert the water which you heat? Archana, yes, close, cooking. Well, heat water. Now, think of it. With hot water, what can else you do? How can you improve the properties of refrigerator? Tell. Is there any refrigerator in the world which keeps food cool and also warm? Have you come across any refrigerator? Anybody, anywhere in the world? Dhruv made one. He took the waste heat, put water chamber around the heat, around the compressor, took the heat up to the top of the refrigerator, put a chamber there with the coils around it of hot water. Now there was a chamber of hot, keeping the food warm. You don't need casseroles anymore. And you have refrigerator for keeping things cool. It has not yet become a product, unfortunately. But it should be possible. When compressor works less because it is cooled, you use less energy. So think of how heat exchangers can be used for using waste heat. There is a company in Hyderabad which uses a small attachment on the stove, cooking stove, wood stove. And now with the heat converted into energy by using bimetallic sheets, the heat is converted into energy, and that energy is used to charge the phones and use LED light. But why wouldn't these solutions become very popular? Why wouldn't we be able to make them at low cost? Why wouldn't we be able to distribute this under the public energy saving policies of the government? So, Rupaprata, my question is that I'm provoking, you are able to think very fast. I will not be there with you all the time. But you need to get provocation all the time, because there's an opportunity lying in every place where energy is wasted. We can find some useful solution. So this should become our second nature. In this break, just think about what should we do so that we start noticing the missed opportunities of either using waste heat or using a waste or not using the information available in the soil or in the water. We are not able to develop solutions for specific niches, for specific communities. We're not learning from solutions that they're developing themselves, knowing fully well that open well doesn't release arsenic. Why wouldn't that become a public policy? Why wouldn't CSR come with a policy document that please don't use hand pumps? Or if you want to use hand pump, put the hand pumps in the open well, not like a tube well. That could happen. That is possible. If your lab will say that, the country will change its policy. UNICEF did not consider this idea. UNICEF mindlessly applied this solution everywhere, and they replicated the problem. They didn't solve the problem. They multiplied the problem. So before, yes, Shehbaz, you're right that heat dissipation is required, but then cold chamber or a water chamber will take the heat faster, isn't it? The dissipation will not be obstructed. The dissipation will not be obstructed. We want to dissipate it. So thank you, Rupapata. So now we have seen 3 cases: water, soil or mineral, food, and third was energy. And energy, we saw both innovations that students and young people and the old people have developed, and how we could learn from them various principles. So we will see one more example in energy. Let me share. Now, this is an example, very interesting example of how a very low-cost windmill-based hand pump operation from Assam again was brought to Kutch in Gujarat for salt farmers. So this was a technology transfer from people to people, from Assam to west tip of salt workers, Kutch, little run of Kutch in Gujarat. There were two key heuristics. First of all, let me give you how 4 levels of learning from an innovation can be illustrated in this example. Artifactual is windmill to windmill. That is artifactual. Metaphorical is if I can use a different kind of gear to run a hand pump to pump water for irrigating my small paddy field, then slow motion can also be productively utilized. So I don't always need speed. We don't need always high RPM. In fact, when motorcycle-based plowing machine was developed, the innovator Mansukh Bhai Jagani had to reduce the RPM from 3,200 per minute revolutions per minute to 1,200 revolutions per minute. How did he do this research? He didn't have a calculus. He didn't have engineering training. He was only 5th or 6th educated. He attached a flywheel on the rear wheel and reduced the RPM and increased the torque. Now, relationship between revolution per minute, the speed and torque, and from torque to the pulling the plow, all this he worked down in his mind and made a machine which got patent, as I told last time, in US. So in 2003, and there are 200 fabricators who have been inspired by Mansukh Bhai Jagani's innovation of 1992 and are now making 10,000 small tractors and different machines. So coming back, one is artifactual, windmill to windmill. Second is metaphorical or analogic, which means using this concept as an analogy and applying it elsewhere. Third is heuristic. What are the 2 heuristics that he used? First was whether I fill my paddy field in 4 hours or 40 hours. Does it make a difference? In fact, slow irrigation is more efficient. Slow irrigation is more efficient. Why? Because leaching of nutrients takes place less leaching takes place. It is healthy. Soils need moisture, not water. Crops need moisture, not water. Second heuristic, it is the hand pump is a single valve. So water will not come continuously. It will come and stop, come and go, and come and go. Does it make a difference to the crop? It doesn't. So which means that sometimes the slow movement may be more effective. The whole slow food movement in the world started on that if you cook slowly, less nutrients are damaged, more nutritious, more taste. That's how the slow food movement started in Italy and spread to all over the world. Second, irregular. I mean, you use fluid dynamics and try to make the flow of the fluid in a particular chamber or a boiler smooth. But maybe an erratic flow could have been more efficient than the smoother flow. We don't know. So the question is that the heuristics implicated or derived from this example of this grassroots innovation could be applied in industrial plants, in boilers, could be applied in chemical plants, could be applied in mechanical system, wherever. So it's very important that we realize that these innovations need a lot of improvement. For example, when wind speed in Kutch was very high, 20 kilometers per hour speed, per minute speed, then naturally the stopping of the windmill becomes very difficult. And stopping becomes difficult. Therefore, you need a mechanism to turn the wheel, turn this windmill so that it can be stopped. Women will find it difficult to do. So you need to make it easier for women to do that. All of those were design problems which we faced. and students from Netherlands worked on it and so on. But some of you might find this is still a challenging problem and help us solve it. So we can learn from grassroots innovation and then comes the Gestalt, which is the ecosystem. So the Honeybee Network provided the ecosystem for these innovations to come. It identified a need in Kutch, linked it with a source in Assam, linked Assam and Kutch. We brought Mushtaq Ahmed and Mehtar Hussain from Assam to Kutch. They came here, they fabricated the design, looked at new materials, salt area, a lot of salt in the wind. So the bamboo and other structures might not work. So they had to convert the bamboo windmill into a iron windmill, but iron also gets corroded. So that was another problem that was generated later on, second generation problem. So there were a lot of issues there, but still an experiment was made. Several windmills were installed and a lot of lessons were learned. So this is another example where we can see how we can learn from innovation at different levels. Now, let us see what we have seen so far. What are we talking about? We're talking about that once we identify the need, we also recognize that the need can be met and degree of diffusion of the solution will be localized, will be wider, will be in one domain, multiple domains, could be centrally distributed, could be decentralized, etc. etc. There are different kinds of institutional mechanism that we can find: multifunctional, single function, bonded, blended, etc. Now, this is the example that I had given you about the refrigerator, where there's a hot chamber on the top, and Dhruv from Asana had designed this. And you can make it better. Companies have not done it. Companies have not done many things. Never use the argument that because companies have not done it, it may not be viable. Companies have not realized that when you take a tray out from the fridge, the things which are lying on the back side of the fridge, on the tray, that takes more effort to bring it up. So you have to remove all the things in the front and then bring the things back. One student gave a very good idea. He said, why can't fridge be cylindrical? So you can rotate the tray. Front portion of the tray will go to the back will come in the front. Taking things out from fridge will become easier. No company has done it. They came to see that in Rashtrapati Bhavan when we had showed this example, but they have not made it. But it's a beautiful idea. Many of you who have faced this difficulty in taking things out from the back of the tray would have realized that if it was round, we could have easily rotated the tray and brought the things moved. And some of you might know that on the table, we have a serving table. We have a tray, which is rotating table. You keep different things and people move them and take the things from the bowl so that you don't have to disturb the bowl. Just move the table and the bowls move. China almost invariably has such dining tables in every party they use. India doesn't do that very often, but China does it. Now, this is an example of how multifunction. This is another example. I told you about how motorcycle-based flying machine and different examples are made. But the point I'm trying home is that when they removed the back wheel, attached an axle of an old car, they changed the RPM and increased the torque so that it can be used for weeding. Here they can make it on a standing top of the car. This I've already discussed, so I will not get into that. Let's come here. How do we assess unmet needs? There are two dimensions here: assurance and capacity. What is assurance that if I articulate my need, it will be met or responded? How much capacity do I have to bridge the need myself? Or the people who want to give me assurance, do they have the capacity to fulfill their assurance, both supply side and demand side? When both are low, that means my assurance is low, no point in telling anybody, nobody will pay attention. And capacity is low, you have unfelt needs remain unfelt for a long time. Apathy is there. What do we do there? We bridge the need. So in many places in desert, many African countries, In some parts of Rajasthan, once it was tried. You had a camel library. You wanted to distribute books, but there was no way that every village which has 10 people, 20 people could have a library. So you had a mobile library. That was a solution to bridge the need gap. There are many other examples you can think about where the need is closed, the gap is closed by providing the solution. When assurance is high and capacity is low, what do? You announce the need. So we have plastic waste, and Dr. Vishwanath from Thiagarajan College of Engineering in Madurai found that it could be used for making roads. A new need was identified. A sector which never used plastic waste, always used bitumen, was identified as a sector which could use 10% plastic waste. So need was modified. Our need was not just plastic waste. Some of you have mentioned in your spreadsheet. This is a case where assurance was high. It became a policy. Mr. Gadkari announced a policy that in highways we can use up to 10% plastic waste. This person had worked for 20 years. Nobody paid attention. When the attention came, the policy got changed. Third case is when capacity is high, assurance is low. You develop solutions, you develop innovation. In this case, child labor. Mansukh Patel found that people use children and women work together to remove the cotton shell, lint from the shell in a grain-fed variety 797. These are not like hybrid cotton where you can just pull the cotton out. These are balls which don't open. So you have to take the cotton and pull it out with force. So he developed a cotton stripping machine which eliminated the need of child labor because he had the capacity. He was innovative. But there was no guarantee that government will use it. So he didn't care about government will meet the need, whether CSIR will look at this problem and solve it out. He didn't care. He didn't look for any assurance. And there was no assurance. But he had creative mind. He solved this problem, eliminated the need. And the fourth is where both are high. Capacity is high, assurance is high. So we found that when COVID-19 started, people developed so many different solutions ranging from Bluetooth to physical distances, shops keeping wire, thread, having a delivery chute. So you keep the things here, they will go to 6 feet away to the customer. Customer will put money in another tray. They will pull the tray and take the money. So there was no direct touch. People followed. So many solutions came all over the world on distancing. The need was transformed. Sometimes the distance was kept, sometimes the touch was not there. Sometimes, for example, in some banks, they started doing ironing on the currency notes because they thought currency note might get virus, and they ironed it, virus will be killed, and then they could touch the note. Many solutions. They just transformed the need to different dimensions. They looked at different dimensions of virus and tried to deal with it in different creative ways. Different creative ways of distancing, different creative ways of killing virus. Some were effective, many were not effective, but nevertheless, there was a huge creative upsurge around the world. Some good, some not so good. Last time I had mentioned example of dispenser of sanitizer or hand washing water, and so many designs came up all around the world. Let me just put the table. All over the world, we came out with so many solutions. So I'll stop here and leave time for you to ask questions. Let me see. Any, I have few examples, I'll share them later, but if you have any question now, we can, and I will show you the spreadsheet later on, where I have marked a few examples, but you can also pick up those examples of unmet need, which you may like to discuss now. Our concern is, how do we convert innovation that people make into identification of needs? I'll show you some examples how PhD students have done that and got an award, Gaffey Award of 15 lakh rupees. As any one of you can apply for that. at barek.res.in under GYTI Sitare GYTI award. So I'll give you some examples of that, but let me wait for some time and listen to your comments on some crazy, some innovative examples of need that you've identified. Otherwise, we would have missed it if you had not identified them. Any example? Raghavendra, go
Hello,
ahead. Yeah, go ahead. Go
sir.
ahead, Raghavendra.
I think customization of chemical fertilizer is a good option.
Customization meaning how much you should
Uh,
apply, where
that
you should
means yes, that slow release fertilizer. Hello.
apply. So what you mean is that we can save the quantity of application time. Okay, Sunil, go ahead, Sunil.
Hello, sir. Am I audible, sir?
Yes, you are.
Actually, what I'm telling to you, just like a stove of acids can be used as a fertilization or sanitizing
Correct.
of hands.
It is used. It is used. The ash is used in the villages for cleaning the vessels, for cleaning hands, and of course, as a pesticide, contact pesticide. That means you put it on the leaves,
But
and
but
yes,
yet
yes.
it is not reported in that research field. That's why I'm telling to you
No,
that
you will
can be
find.
characterized.
No, you will find a lot of research papers on use of ash or potash. Just write ash and uses, test, and other things. You will find natural pest potash as natural pest control, natural fertilizer, fungicide, and a lot of examples are there. So please
Okay,
look
so
up.
because
Look up.
in India, actually, a lot of persons are using like stove of acids
Correct.
of different woods, like what we called that in biogas. Also, we use that things, so that
Yes.
can
Yes.
also uh, in different state that also store that dal bati and all things
Correct.
using
Correct.
that
All that
stove.
ash can be. You're absolutely right.
Yeah,
You're
yeah.
absolutely right. Yes. Yes. Yes.
So that
Uh,
SS is waste. Like they don't use for that things for that fertilizer.
Not enough. Not
That
enough.
can,
Not enough. But they should. You're right. It's a very rich. It is rich in potassium and phosphorus also. Very good source of potassium. So you're right. We must
can
encourage
be
that.
unmade.
Yeah. Okay. Thank you. Roshni, you have mentioned use of turmeric for milk adulteration. Can you just speak up a little bit on that? What are you saying? I'm not aware of that. Can you just tell everybody?
So I had this idea in my mind as when we it gets orange and red. So and even if we add turmeric in milk, if it has detergent in it, it will turn red. So can we use such thing?
Yes,
Or
it is definitely possible. There is an award we gave. I'll show you in the next, after 10 minutes, 15 minutes, I'll show you some example where melamine, what is it? Melamine as an adulterant in milk. One student developed a very low cost solution and he was given an award of 15 lakh for that. So what you're saying is a very good point, and we must pay attention to what you're saying. If you can develop some protocol for that, by all means, it will be very, very useful for people. So please do take it forward. Anybody else? Raghavendra, you mentioned that CSIR ITR made an instant test kit for milk adulteration. I think we should find out more about that because these kits need to be given to Operation Flood agencies, AMUL, and others, so that they can try to find out kinds of adulterant, both at the point of collection, which is cooperative dairy, rather than at the kind of processing. By then it is too late because the whole lot will get damaged. So if at the point of collection we can have a low cost strip test or something like that, which can immediately tell, that will be very nice. Akshay, there is a coconut water storage technology. You can find it in the market. Online you can buy. I have been buying coconut, packaged coconut. Kerala has developed, many companies have developed. So there are technologies available now of packaging coconut water without using preservative. You should look it up. Any other need? Anybody else? sanitation requirement or drinking water problem in Uttarakhand, very important issue, because though there is a lot of spring water, this is a question that all of us should reflect on this point. I'll come to you, Ashwini, 1 minute. So what happens is that animals go for grazing, and when animals go for grazing in the catchment area, they also there is an animal dung lying there. And E. coli will diffuse in the streams. There's a general principle in mountain: never drink water which is flowing on the surface, even if it appears crystal clear. When we go with my students to Himalaya, this is the first condition I will tell them: never, never, never. Only water which oozes out from the rocks must be used for drinking, not the water flowing above the surface. No matter how clean it is, you can't fill it in the bottle because it may be full of E. coli drained from the excreta. So you are very right that though it appears that there is a lot of water flowing in the mountains, in the streams, but it may not be fit for drinking at all because of the E. coli distributed by the dung of the animals. Yes, Ashwini?
Yes, sir. I would like to share an idea.
Yeah.
We are all aware that healthy persons require a certain number of calories per day.
Yes.
So if we can develop some kind of a device which would constantly monitor the intake of calories and tell the person at say maybe at the noon hour how much calories he has taken so far and how many more calories he can take for him to remain healthy. So,
there are apps available of calorie calculator. So you just mentioned what food you have taken, and I'll just show you this. So you can see that 5 best calorie counter website and apps. So these are different solutions that are available. MyFitnessPal, it tracks your weight and calculates the recommended daily of calorie intake. Then you can mention what you have taken, and it will tell you what can you eat now. Lose It app, another health tracker, use easy to use food diary and exercise log both. So if you do more exercises, you can consume more calorie. If you exercise less, you should take less. So there are solutions available, Fat Secret and so on. Please look at them: chronometer of diet, exercise, and body weight also. There are 3 dimensions that it is tracking, so that you can have a target of weight, target of food, and then
Hello, sir. Sir, I would like to talk something about the drinking water issue. I have seen in
Yes.
Facebook 2 videos. So
Yeah.
it was actually people in mountain areas trying to collect fog as a drinking water source. They have planted some nets so that they will catch this fog, whichever is being wasted every day during night time or in the morning. So these nets will collect this fog, and drop wise it will collect as a whole. We can get the pure drinking water. That was one. Another version was like people try to make a fountain, which this is especially in cold areas like more icy areas. So where they try to make a fountain so that this fountain will instantly become ice, so that ice can be converted as like drinking water. That will be
Correct.
uh,
It is called
drinking water.
snow stupa. Snow stupa. In Ladakh, there was a very famous person who had designed this, and this is now being popularized by other people, but it was designed by a rustic engineer, so to say, a grassroots level worker, who made these snow stupas or ice stupas. You can call them artificial glaciers. These were artificial glaciers made for water. I want to just show you, Manoj, I'll come to you in a minute. I want to show you a very interesting innovation in the context of water in the mountain. In mountain, you have a lot of pine trees, isn't it? So what this student has done, she and her under the guide of Dr. Kulkarni at MIT, and her name, Kritika Ramchandar is the student, and she's a student of various Karnik. Rohit Karnik is the professor of mechanical engineering I had visited his lab long time ago and seen this experiment. What have they done? They have used the xylem, the wood of pine, which is put in a tube, and water goes through that tube, through that pine wood, and it gets filtered. Very simple. One of the most low-cost solution for water filter, a natural pine wood. That's it. And what are they trying to do? Look at here. Their xylem is comprised of conduit that are interconnected membranes. And there's a very good research that they have done. They have seen that xylem filters can filter even E. coli and rotavirus in the lab test. Filtering can remove bacteria, and then they know that it has to be cleaned up after a while. You have to clean them from certain kind of solvents, and then this will can be re-good. Filters appear to be self-block over time. That means they have clogged the content. Then you have to either remove them or sap them in hot water for half an hour and then dip them in ethanol and let them dry, and they are ready to use again. You don't have to get fresh wood, but you can easily get fresh wood if you wish to. Such a simple idea, I don't know if you can see this video. Zaid, can you see this video? Are you able to see the video?
Yes, sir.
Yes, sir.
Look at this. Room temperature, the wood piece has been taken out. Ethanol. Simple experiment, no complication. You can do it at home. She's the one who has done it. Right? Now, put it in the tube. And xylemwaterfilter.org. Technology is ready. Now, this is a beautiful example of extremely frugal solution. Yes, crockery made of leaf is also a very good example. Extremely frugal solution have been developed by using nature as a guide. Properties of nature have been harnessed. I will discuss with you in the next class about how we can learn from nature and different properties of nature we can harness. But this is a good example. Manoj, go ahead, please.
Good evening, sir.
Good evening.
I'm Manoj from CSIR NPL New Delhi.
Yes.
I would like to mention that the burning of the fossils is a big problem.
Yeah.
Whenever there is a season of cutting crops like paddy and wheat.
Go ahead.
So there should be some technology that actually the combines that cut the crops. They have left the crops a certain height, and we should innovate some in combine machines that it should left the crop straw very little. A small initiative can rescue big environmental pollution problem.
So now what I would like is, Manoj, that some of you should take up such challenges and do a review paper on what innovations have been done. How, for example, I have seen crockery made. One of the Gyati Award we gave to some students in very ordinary University of Chandigarh, Chitkara University. These boys, what they did? They used mobile microwave in the field attached to a tractor for processing crop waste. Can you imagine? So there are different people who are using very fascinating idea. IIT Delhi has a student, Kriya Lab. They are making crockery out of waste by making some kind of paper which can be used for crockery. You can take tea, your plates, cups, and all of that. They are using biomending materials, so on, mushroom cultivation, fuel, and so on. So my suggestion is that some of you should now start taking up problems which require a massive review of literature, of what is done around the world, in the country, where are the gaps, and then identify and give a direction. Even if you don't want to fill the gaps, at least your review paper will tell the upcoming startups, entrepreneurs, young students. They will say, oh, there is a niche that has been identified here. Maybe I should work on that. Maybe I should try to find out how this can work better. So, for example, water filters. There's a huge opportunity for water filters. Even poor people would like to use it if they can afford it, because who wouldn't like 60% diseases? Please remember, 60% diseases in our country are waterborne. So naturally, we need good water filters. And maybe you know that the Godrej, or was it Godrej? Yeah, Chota Cool. Was it Godrej or Tata's? Tata's, I think. They have developed the straw of the crop waste was used and impregnated with silver nanoparticles, and they were trying to use it as a water filter. Unfortunately, the solution, the technology of impregnating the straw with uniformly with nanoparticles of silver could not be very well mature, and therefore it didn't succeed in the marketplace very much. But idea was good. You could develop a very low cost straw into a high value water filter. So think of various challenges that are lying before us and come out with a review, identify some solutions, unmet needs, and then give your direction. Where would you like us to focus? Where would you like country to focus? And maybe these kind of reviews by you, all of you together in a group of 5, will do wonders for the country, because there you will review the knowledge from the grassroots, you will use traditional knowledge, you will review research paper, and that could really become a powerful statement on the unmet need. We could then, Ashwini and Dr. Sangwan, we could then bring out a state of unmet need report of India. You know, every year through this course, we can make a state of unmet need. That means we will put on that. Nobody can say, I didn't know this. Your reviews will put on the table all the unmet needs in different domains after review of both grassroots innovation and formal sector innovation. So you would have done a justice. 5 of you, one topic, say water filter. I mean, you could review different water filters, and then you can review what are the missing things in these water filters. You can also look at the MIT water filter of wood-based water filter, and then evaluate it, and then say, okay, this will work under this condition, this will not work under that condition. The flow rate will be low, so we need many tubes for getting the water. But then maybe you will find out that for a household, 5-tube water filter will give you enough water flow in an hour that a family of 5 can get enough water to drink every hour for that matter. So there could be different ways in which this can be done. Yes, Rao, you are right that there floating inflated polysterenes can be collected and make some hollow bricks. You are right. Many of these solutions are working out. People are making tiles out of it. People are making bricks out of it. People are making joints, Lego blocks out of it. So review is very important so that you know what is being done around the world. Anybody else before I want to show you something quickly? Anybody else? I will show you some award that we given so that you get excited about how we could encourage your innovations. So if you do a review and you come out with good solutions, look at what we have here. So let me begin with Vikas Pandey's solution, which is my favorite. He was in IIT Delhi doing PhD, and he found a very simple problem that TB, we want India to be free of TB, but TB bacterium requires fluorescent microscope. Fluorescent microscope costs about 8 to 9 lakh rupees. He used a normal microscope, which is about 25,000 rupees, and made it this attachment, which also costs 25,000 rupees. And now your ordinary microscope converts into a fluorescent microscope in 50,000 rupees or 60,000 rupees. He has set up a company there, which can now be given to every primary health center, and TB can be diagnosed more accurately and precisely. Early diagnosis means TB is not treatable, so we can get rid of this disease. Isn't it a good solution? 60,000 rupees, fluorescent microscope, which cost 8 to 9 lakh rupees. Many of you might need this in your own research, and you might be able to then work. So this is one example. Let me take another example. Sonam Wangchuk is replicating. He has not developed the concept of glacier. He is only replicating it. It is the person who has developed it. If you search on the Google ice stupa, you will find the name of that person. Let me go further. Bioseparation, new technique has been developed. He has developed, set up a company also, Jayesh Mewada and Prateek, handheld melamine detection device for milk. You were talking about low cost. Professor Sibasai Gotri, who has done work on microfluidics at ISC Bengaluru, under his guidance, these students got a PFA award from NIPER, a very interesting microsampling for blood sample to be sent to the lab. Normally, you ask somebody to come and do that. You can take your own sample, and it can be used for various kind of applications. This is a corneal matrix. We can go further. 4D tissue injuring. So I just took some example where the companies had been set up by the students, convert their innovations into enterprise. And I would like all of you to invite you to apply there. I mean, so there are two things I'm saying. One I'm saying is that we should make groups of 5 across labs, across disciplines if possible, to take up one unmet need, do a thorough review of both grassroots innovations and the solutions that are available by the scientists, by the students, and then make a state-of-art review and then identify the gap and give your priorities. If somebody wants to spend his or her next 1 year or 2 years or 6 months on a problem, these are the 6 ways in which you can solve the water filter problem better. And people might follow them, might modify them, that's up to them. But this could be a very good way of triggering solutions to the unmet need which have remained unsolved for a long time in our country. So we must break the inertia. We must be able to help these courts put on the table not just the problem, but also the ways in which people have tried to solve it globally, and then try to find solutions. Yes, anybody else wants to say something before I proceed further? We have a few minutes, and we lost some time due to the YouTube thing. It worked out now. So anybody try to capture today? First thing was, we said that when we look for unmet needs, we try to see how innovations themselves can be a trigger for the unmet need. Then we also looked at how the obvious needs to be out so that we don't get bogged down by the incremental changes within the small range. So when we talked about cycle, we said we're not going to talk about transporting people. We're not going to talk about transporting goods. We're going to talk about other uses. So children could come out with a lot of very different application. Now come to think of it, if you want to use cycle for grinding, cutting vegetables, making juice, we don't have a pivot on which you can put the grinder or anything else. Now on the back seat, below the back seat on the cycle, there could be a small pivot attached to the wheel. So you keep it a cycle on the stand, rotate it with the pedal, and now you have a motive force available to do various kinds of juice, vegetables, salad, whatever else that you want to do. A small enterprise can be supported by a cycle, but we have not done it. But we can do it as a retrofitting device. Somebody can make it. So some of you should think about it. This is a need unmet for decades, and I don't know why we have not done it. No cycle manufacturer is interested in it. Doesn't matter. We don't bother about it. We will do that because then people can attach it to various kinds of cycles. Just as dynamo used to be attached to the cycle, we can attach this pivot, and on that pivot maybe of standard size so that any grinder or mixer can be, or blender or cutter can be adjusted. So therefore there could be different kinds of solutions that can be devised. We also looked at different ways of self-learning from innovations, artifactual, metaphorical, heuristic, and gestalt. We then try to look at change not monitored, change not desired. We looked at 5 challenges. We have not been able to complete 2 of them, shelter and health. We did not discuss in great detail, but we discussed food, we discussed water, we discussed energy. And there are a lot of dimensions of this problem which we have not yet addressed, but they need to be solved. So that we looked at. We found out how grassroots communities manage energy and how could we learn from them. We also looked at how do we deal with needs. Some needs need to be eliminated, some need to be enhanced, some need to be transformed, and some need to be just bridged. So there are 4 ways in which needs can be tackled. We looked at all the 4 examples and tried to see not every needs need to be met. Some need to be replaced. Child labor, we don't want any solution for child labor. We want to remove child labor. We just don't want to tolerate this. So there are needs for which we don't develop solution except by eliminating them. So please think about it. Every need which we try to meet also involves the expression for our values and ethics. Our values are not independent. Science is not independent of our value system. Science is reproduced in a scientific, in a social context, in a cultural context, in an ethical context. So whatever choices we make have implications for people and for science. So please don't think science is a neutral subject. It is highly influenced by our choice of parameters, choice of the trade-off that we make and so on. So I will close here. I will leave it to you